Here we have the 2017 question 8. This is Junior Cert Ordinary Level. This is paper 2 and this is a question on trigonometry, and it also brings in a little bit of geometry as well. So the diagram below shows part of a climbing frame. The points B and C are on the ground, so this must be the ground here, and the legs OB, so OB is from O to B, and OC, O to C, are joined by a horizontal bar which is PS, so this is a P here. And then, so Ava measures the angle that each of the legs makes with the ground. She finds that they are both 55 degrees. So these angles are both 55 degrees. What type of triangle is OBC? So OBC is the whole large, the side with OBC. So only have them as all our corners. So what type of triangle is this? Well, first I'll go through the different types of triangles. So if we have equilateral triangles, all the sides are the same and all the angles are the same. If we have an isosceles triangle, we have two sides that are the same, and then the two angles opposite these sides are also the same. And when we have a scalene triangle, none of the sides or the angles are equal. So this is equilateral, this is isosceles, and this is our scalene. So first we could check, well, if we add 55 and 55 together, so we can get, so if we want to figure out what this angle is, just to make sure they're not all the same. So 55 plus 55, we get 110, and then we can take that away from 180 take 110, and we get 70. So this angle here is 70, so we can be pretty sure that it's not an equilateral triangle, so it must be an isosceles, because these two angles are equal, which means these two sides must also be equal. So we could say it is an isosceles, because in isosceles two of the angles are equal. Two of the angles are equal. So then in part B, we're told to work out the size of angle O at the top of the frame. Well, we actually just worked out the size of angle O in the last part. So we added 55 and 55 together to get, say we're dealing with this big triangle here, and then all the angles in a triangle add to 180. So 180, take those two angles and we get 70. So that was angle O. And it tells us that OBC and OPS, so OBC is this big triangle on the outside. And then I'll just get a different colour to do the one on the inside. And then OPS is this one here, outlined in pink. And they say they are similar triangles, so explain what this means. So similar triangles, they have their angles are the same, so their corresponding angles are the same. So say this angle is the same as this one, this is the same as this one, and in the so in the larger triangle, these both actually have this angle here. So similar triangles, their angles are the same, but their sides are in the same ratio. So angles are the same, and then the sides are in the same ratio. Same ratio. So we're told, so I'm just gonna do out another diagram here. So this is the diagram I was given, so I'm gonna be asked to do a question on this PS, O, B, C, and this is 55, 55, 1.3, and 70. So my smaller triangle is this one here, and my bigger triangle is this whole one here. But we have to consider them as individual triangles. So our smaller one, we can even draw them out, OPS, and then our bigger one is OBC. So we have to consider them as their own, they're triangles in their own, they're actually triangles themselves each. So we were told that these triangles are similar triangles. So Then we are asked, that was in the part before, and then so they tell us PS, so we know that is 1.3. The point P is halfway between the point P is halfway between the point B and O. So if the point P is halfway between the point B and O, well then the length from P to B is equal to the length from P to O, because it just divides it in half. So that's equal. So we are asked to find the length of BC. So if we consider, say, these triangles, so with similar triangles, their sides are in the same ratio. So whatever we had to do to the length of this side to get to its corresponding side of this side. So say, maybe if we consider them as separate triangles first. So whatever, so the length of from O to P, say if we multiply that by 2, we'll get the length from O to B. So the length of this side is half the length of the whole side. So if we consider that what we had to do to get from OP to get to the whole length was we had to multiply by 2, because it's half of the total. So say if we call OP, whatever we call it, say we could call it X, well then the length of the larger side of the bigger triangle is going to be 2x. So the rule is we multiply by 2. So whatever we do to one side to get the other side, its corresponding side, we do to, say, the other side to get its corresponding side. So the rule is we multiply by 2 to get the bigger triangle. So 1.3, if we want to get what BC is, we have to then multiply 1.3 by 2, because the rule is, it's the same rule for all the sides. So then we get that BC is equal to 2.6. So the sides are in the same ratio, so whatever we do to OP to get this bigger side, which is multiply by 2, we do to this one, and we multiply by 2 to get the bigger side, and we multiply this side by 2 to get the whole length of the bigger side as well. And that is the basic principle of similar triangles. And that is our answer for that. Thank you.